Hi all, I am Rutvik and this is my deep learning exercise for deep learning sixth in class exercise programming based on autoencoders. Our task is to build a simple autoencoder for reconstructing an existing image based on MNIST dataset. And for that we create and we add tensor board graphs and also modify add an additional hidden layer and add an activity regularizer and compare the loss as well. So I've done it in Jupyter notebook and you can find the code here. So this was the given code by the TAs and it describes in encoded with the dense layer of shape input shape. I mean encoding dimensions of 32 and an activation of ReLU function. Similarly on the decoder end with a sigmoid and the same dimensions as in the input image. Then this is how we create a TensorBoard graph and we call this in the callbacks while training. Make sure that you add the metrics as accuracy in the compile function. So once you fit the data set and pass the callbacks as TensorBoard, that is the one which we created earlier, it plots the results in the logs. So I've trained it for 10 epochs to get the results quick, and then we plot the image with the reconstructed one. And the third question there is one is to add the hidden layer and the other one is to an activity regularizer. So this is how we add an activity regularizer, and the rest of the code remains the same. This is the hidden layer with dimensions of 16 and 32 on the encoding side and the decoding side, and the rest of the code is just replicated from the uh, above slides or above code. And even this is trained on 10 epochs. We see that the loss, you can compare the accuracy, it's close to 80 here, and for this it's the same as well. So the performance wise not much difference, but it's a variation of autoencoders. And once we visualize these, you can see that this is the accuracy plot and this is the loss plot, which can be found from the tensor board as well. So this is the latest one and this is the old one. More details can be found on my GitHub repository. Thank you so much.